All right, diving right in today. Looks like someone's been digging into the composite design pattern. You've sent over some articles and even a YouTube video, so wow, let's unpack this.
Yeah.
The goal here is I want you to walk away actually knowing how to use this thing.
Right.
Not, just be able to kind of like spit out the definition.
Right.
No textbooks here.
Absolutely. Yeah.
Yeah.
I think the composite pattern can be a little intimidating when you first see it,
Yeah.
but it really boils down to a very practical problem that we see in code all the time.
Okay, so the composite article starts with this example of trying to figure out like the total price of an online order,
Yeah.
which sounds pretty simple, right?
All right.
But then they throw in boxes.
Yeah.
And then boxes within boxes within boxes, and suddenly it's not so simple.
Yeah. You can imagine, like, if you were trying to do that in code without a design pattern, you'd have to, like, write specific logic for each level of nesting. Like, what if they're 5 boxes deep, 10 boxes deep? You'd have this just big nested mess.
Yeah, that sounds like a debugging nightmare for sure.
Yeah.
So how does Composite solve this? Because the article keeps mentioning like tree structures, but I'm not quite picturing it.
Yeah. So think of it like an actual tree. You have the trunk and it branches out, and there are smaller branches off of that, and finally you get to the leaves. And so the composite pattern, it basically each leaf would be like a simple element, like a single product in your order. And the branches would be containers. They can hold other containers or leaves.
Okay. So I'm starting to see this like a box in my order would be a branch, and it can hold either, just like a product, or it could hold more boxes.
Exactly.
Yeah,
Yeah. And the real key insight is that with the composite pattern, you can treat a whole branch the same way that you treat a single leaf. So you don't need separate code to handle each one.
Wait, how's that possible? A product and a box are totally different things.
Right, so this is where the magic of interfaces comes in. So both the product and the box implement a common interface. And let's say it has a method called calculate price.
Okay.
And the product, when you call calculate price on a product, it just returns its own price. Simple enough.
Easy.
But with a box, it delegates. So it calls calculate price on each item inside it, adds up the result, and then returns that total.
Oh, I see. So even if a box contains other boxes, it just keeps going down and down and down until it gets to an actual product to get the price.
Exactly.
Yeah, like a chain reaction.
That's the power of recursion. So the box doesn't care what's inside it. It just applies the same logic to everything. And because everything's using the same interface, your code stays clean and manageable no matter how complex the structure is.
Wow, that is actually pretty elegant. So is this just about calculating prices, though? Because the composite article mentions a military example as well, right?
Yeah. So you could think about the structure of an army. You have divisions, which contain brigades, which contain platoons, down to individual soldiers. It's another tree structure that you see in the real world.
So just like you could calculate the total cost of everything in a box, you could, count all the soldiers in a division, even though they're kind of nested down into these smaller units.
Yeah, exactly. So anytime you can organize your data hierarchically, where you have containers holding other containers or individual items, this pattern works. And they could be, physical objects or data structures or even abstract concepts.
Okay, that's making a lot more sense now. I have to admit, when the composite article got to the pseudocode for a graphical editor, I started to get a little lost again.
So let's break that down. So they talk about this compound graphic class, which is essentially a container for shapes. And the interesting thing is that this container can hold simple shapes like circles and dots, but it can also hold other compound graphic objects.
Oh, so you could have a compound graphic that represents a whole car.
Right.
And then it contains other ones that are the wheels, the doors, the whatever.
Yeah, like those Russian nesting dolls.
Yeah, exactly.
And the cool thing is that the code that's using these shapes, it doesn't care if it's dealing with a simple circle or this complex car made up of 100 other shapes. They all follow the same interface, so you can treat them all the same.
Okay, so it's all about kind of like hiding that complexity and making it easier to work with these intricate structures.
Exactly. And to actually see this in action, let's look at the YouTube video that you sent.
Oh, yeah.
The one by Derek Banas.
Derek Banas. He's great at explaining things simply.
Yeah, he's very accessible. And in his video, he demonstrates the composite pattern by organizing songs and groups of songs. And he uses this analogy of a disc jockey, which I think is quite clever.
Okay. Intrigued. Tell me more. How does he use composite in the context of music?
Yeah, so basically he builds this system where you can have individual songs, and those would be like the leaves in our tree analogy.
Okay.
But you can also have groups of songs, which would be like the branches or the containers.
So, like, I could have a group called, my favorite 80s hits
Right.
that has, individual song objects inside it for all the songs.
Exactly.
And then maybe I have another group called, like, Road Trip Playlist that contains that 80s hits group,
Right.
as well as some other songs, maybe even another group.
Exactly, yeah. And then the beauty of the composite pattern is that the disc jockey, in this case, can request information about a song, like its title or the artist. And it doesn't matter if that song is an individual song or if it's part of a group. The DJ doesn't need to know or care about the internal structure. It interacts with everything through the same interface.
That's pretty cool. It's kind of like having, like, a universal remote that can control your whole entertainment system.
Exactly.
You don't need separate remotes for your TV and your DVD player and your whatever.
Right. That's the power of the composite pattern. It brings order to this complexity, and it makes your code more manageable and more flexible.
All right, I think I'm really starting to get the core concept here. Like, it's all about representing this hierarchical data in a way that lets you treat these simple and complex elements all the same, right? Thanks to interfaces and recursion.
Exactly.
And man, this is making me think about all sorts of applications.
That's the spirit. That's exactly what we'll dive into next. So let's explore some of the specific benefits the composite pattern offers and how it can be applied in a wide range of scenarios.
Okay, so you mentioned some key benefits to using composite, and one that really jumped out at me in the composite article was how it makes your code so much more flexible.
Yeah, one of the big ones is that it follows the open-closed principle. So remember, that means that you can add new types of elements to your structure without having to modify the existing code.
Right. So like in our music player example, if we suddenly decide, oh, we want to add playlists, we wouldn't have to go back and rewrite all the DJ's logic for interacting with songs and groups. We could just create a new playlist class that implements that same song component interface.
Exactly, yeah. So it's a big win for maintainability. You can keep adding new features and functionality without breaking your existing code base, which is always nice.
Yeah, that would save a lot of headaches, I'm sure. The article also mentioned something about like how it makes recursion simpler. And I'll admit, recursion always kind of makes my head spin.
Yeah, I understand that. Recursion can be a little tricky to wrap your head around at first, but I think the composite pattern actually makes it a bit more manageable. So think about it. With a tree structure, you often need to perform the same operation on every element, whether it's a leaf or a branch.
Like applying a filter to all the photos in a folder, even if some of them are in like subfolders within subfolders.
Yeah, perfect example. So with recursion, you can write a single function that calls itself to traverse this whole tree. And in the context of the composite pattern, that function just checks, okay, is this element a leaf? If so, do the operation. If it's a container, call myself again on each of the children.
So it's kind of like those choose your own adventure books where each choice leads to a new page and then eventually all paths lead to an ending.
Yeah, I like that. That's a great analogy. That's exactly how recursion works.
Mhm.
And because the composite pattern ensures that the leaves and containers have that same interface, your recursive function doesn't have to know the specific type of each element. It just knows how to interact with them through that common interface.
Okay, so that's starting to make recursion feel a little less intimidating. But the composite article did mention a potential downside. Something about, designing the common interface can be tricky sometimes.
Yeah, that's a good point. If your leaves and containers have very different functionalities, it can be challenging to come up with a common interface that makes sense for everybody.
Yeah.
You might end up with an interface that's too generic, and that can make your code a little bit less clear.
It's kind of like trying to design a single remote control that can operate a TV and a refrigerator and a car.
Yeah,
You might end up with a lot of buttons that don't really make sense for every device.
exactly. Yeah. So finding that right balance in the interface design is really crucial. You want it to be general enough to accommodate all the elements, but specific enough to be meaningful and easy to work with.
Got it. So it sounds like any tool, composite isn't a silver bullet, but it's really powerful when used appropriately. And I'm starting to see how it connects with some other design patterns we've explored before.
Yeah, I think design patterns often work together. They're kind of like pieces of a puzzle that you can combine to create really elegant solutions. Remember the builder pattern? That can be a great companion to the composite pattern when you need to create these complex tree structures.
Right, Builder's all about like breaking down the construction of a complex object into these steps, right? So I can see how that would be super helpful for building up these intricate composite trees.
Imagine building a house. You wouldn't just start throwing bricks and lumber around randomly. You'd follow a blueprint, step by step, to construct the foundation, the walls, the roof, and so on.
And with the composite pattern, each room in the house could be like a container.
Right.
And then the furniture, the appliances inside each room, those would be the leaves.
Exactly, yeah. And then the builder pattern would provide a really clear, organized way to assemble all those components into this complete house.
Okay, that's a really good visualization. What other patterns kind of like play nicely with composite?
Well, is the chain of responsibility pattern. Do you remember how that one works?
Yeah, it's like passing a message along a chain of people until someone knows how to handle it,
Yeah.
right?
Right. So in a composite structure, imagine a leaf node receives some kind of request. If it can handle the request itself, great. If not, it passes it up to its parent container, who then checks if it can handle it.
Hmm.
And this keeps going up the chain until somebody can take care of it.
It's like if an employee gets a task they can't complete, they escalate it to their manager, who might escalate it up and up until it reaches someone who knows what to do.
Exactly. And the composite structure provides this natural hierarchy for that chain of responsibility to kind of work its way through.
Oh, I can see how that would be useful for like event handling and a user interface.
Yeah,
A button click might need to be handled by different parts of the application depending on the context.
exactly, yeah. So composite and chain of responsibility can work together pretty seamlessly to manage those kinds of scenarios.
Thinking about traversing a tree structure, it reminds me of iterators. Do those have any connection to composite?
Absolutely. So since a composite structure represents a tree, which is essentially a collection of elements, you can use iterators to traverse that tree in a really systematic way.
So you could use an iterator to like visit every leaf node in the tree or to perform some operation on every element in a specific branch. Like it's like having a guided tour through your data structure.
Exactly. So it provides this really clean and efficient way to access and manipulate the elements within your composite tree.
I'm really starting to see how all these design patterns are kind of interconnected. They're like tools in a toolbox, each one with its own specific purpose, but then you can combine them in really powerful ways.
Yeah, that's a great way to think about it. And speaking of powerful combinations, the composite article also mentioned the visitor pattern. Have you come across that one before?
Vaguely, I remember it having something to do with adding new operations to a class hierarchy without changing the classes themselves.
Yeah, you're on the right track. So the visitor pattern lets you define new operations that can be applied to the elements of your composite tree without modifying those elements directly.
So, like in our graphical editor example, let's say we want to add a new feature that lets you apply a blur effect to shapes. With Visitor, we wouldn't have to go back and modify each shape class, like circle and square and triangle, to add this blurring capability.
Exactly. You just create this separate blur visitor class that knows how to apply the blur,
Yeah.
and then you could just traverse the composite tree, and for each element, you just call the visit method of your blur visitor and pass in that element.
So like the blur visitor would know how to handle each type of shape and apply the blur accordingly.
Exactly.
That's pretty cool. It keeps your shape classes really clean and focused, and it makes it really easy to add these new operations without disrupting everything.
Yeah, exactly. It's like having this team of specialized experts who can come in and perform these very specific tasks on the elements of your structure without those elements needing to know exactly how the task is performed.
I'm realizing just how flexible and extensible this pattern can be,
Yeah.
especially when you start combining it with these other patterns.
It's a testament to the power of good design. But I think it's important to keep in mind that even with all these advantages, the composite pattern is not always the best solution.
Right. You mentioned earlier that, designing that interface can be tricky, and sometimes the complexity of managing a tree structure might just not be necessary.
Exactly. It's like any tool, you need to use it wisely. So if your data is relatively simple and flat, the composite pattern might be overkill. And if your elements have wildly different functionality, trying to force them all into a single interface could actually create more problems than it solves.
Right. So it's all about choosing the right tool for the job. But I have to say, learning about this pattern has really opened my eyes to all these possibilities for working with hierarchical data in a really clean and efficient way.
Yeah, I'm glad to hear that. And there's even more to explore.
Yeah, it feels like we've only just scratched the surface. Are there any other patterns that kind of like play nicely with composite?
Yeah, there are a couple more I think are worth mentioning. These both kind of relate to optimizing memory usage. So one is the flyweight pattern.
Okay.
And it's all about sharing data between objects to save space. Kind of like how a single blueprint can be used to build multiple identical houses.
Oh, so like if you have a bunch of leaf nodes in your tree that are all basically the same,
Right.
you could use flyweight to represent those as like a single shared object
Exactly.
instead of duplicating all that data for each one.
Right, yeah. So it can be a really great way to make your composite structures more memory efficient, especially if you have a lot of repeating elements.
Okay, and what about prototype? I remember that one being about like cloning objects.
Yes, and that can also be helpful when you're building these complex composite trees. So instead of having to construct every subtree from scratch, you could use the prototype pattern to just clone an existing subtree.
So that would save a lot of time and resources, especially if you have like these really repetitive or computationally expensive construction operations.
Yeah, exactly. It can streamline the process of building and modifying your composite structures.
It's like composite is like the social butterfly of design patterns, always making friends and collaborating.
That's a great way to put it. And to really round out our understanding, I think it's helpful to kind of compare the composite pattern to the decorator pattern. So they both kind of use this similar recursive structure, but with different goals in mind.
Right, because decorator is all about like dynamically adding responsibilities to an object, like adding toppings to a pizza. So you start with like a plain pizza object, and then you can wrap it with these different decorator objects for cheese, pepperoni, mushrooms, whatever.
Right. Whereas with composite, you're not adding responsibilities. You're creating this hierarchy of objects that can all be treated uniformly.
Mm.
So it's kind of like comparing a single pizza to a whole pizza menu, where you have categories for different types of pizzas, each containing various options.
Gotcha. But they can still work together, right? Because the composite article mentions something about, using decorators within a composite structure.
Exactly, yeah. So imagine you have this composite tree that represents a user interface.
Okay.
You could use decorators to add things like borders or shadows or tooltips to individual elements within that tree.
Yeah.
And you wouldn't have to modify the element classes themselves to do that.
Oh, that's a great example. It shows how you can really kind of blend these different patterns together to achieve different goals.
It's like having a team of specialists, each with their own unique skills, all collaborating on this project.
This whole deep dive is really like, I don't know, just opened my eyes to how elegant and powerful this composite pattern can be. I feel like I'm starting to see it everywhere.
Yeah, that's the sign of true learning. Like once you kind of understand a concept, you start to recognize it in all sorts of unexpected places.
Yeah, it's like when you learn a new word and then suddenly you hear it like in every conversation.
Exactly, yeah. And as you continue to explore this world of software design, you'll find that these patterns kind of become like familiar friends, guiding you towards more elegant and efficient solutions.
So for our listener who wanted to really kind of wrap their head around composite, what are the key takeaways?
I'd say first, remember it's all about representing data hierarchically, like a tree with branches and leaves.
Hmm.
And the real magic happens when you can treat a whole branch the same way as a single leaf through the power of interfaces. And, of course, remember that recursive nature of the pattern, which allows you to kind of traverse this whole structure with very little code.
Yeah, and it's not just theory. We're talking real practical benefits here. Code flexibility, easier recursion, a more organized way to manage these complex structures. Plus, it plays well with other patterns like what we talked about, builder, chain of responsibility, visitor. It gives you this whole toolkit for tackling different challenges.
Yeah. So now that you've got this understanding of the composite pattern, I bet you're going to start to see all sorts of opportunities to use it, maybe in your work, in your own projects, even just in how you organize information in your daily life.
Keep an eye out for those tree structures, and if you come across any particularly interesting examples, we'd love to hear about them.
Absolutely. Until then, happy coding.
And happy pattern spotting.